Let's clarify our objective here. It is to get good grades without any silly shortcuts. Because to score well on the ACT or SAT, you don't get to use silly shortcuts, you can't use ChatGPT, and you can't cheat. If we accomplish these goals and we understand the reason behind them, we will learn the concepts along the way. We might even enjoy it a little bit. Maybe not, but that would be awesome if we do. What's the problem with most school math? They need to get a certain number of you to pass, and you're learning it on a little computer. Neither of that is good for you. You end up bored, and all you learn is how to fit little patterns into Delta Math, and as soon as they change the questions a little bit on the test, you freak out, and you have a bad experience with math. Here's the thing. I don't care if you actually end up good at math. I need you to do well on the SAT and well in your classes, and that's what you really care about. Fine. That will improve your relationship with math. That's the goal here. It's not that scary. There's a lot of patterns that build. Basically, if you can do math 2 really well, you're good until calculus 2, maybe even calculus 3. As you get more comfortable with it, you will learn more. I promise when you get a 95 in a math class, you're going to know more of it when you do it the right way. So, why does this even matter? Look, your calculator, ChatGPT, your mom, your dad, your coworkers, your classmates, some of them will be able to do math for you. If you're smart and you understand how to navigate it, you might even be able to get them to do all of the math for you in the real world. That's fine. That's not the point. The point is that math 1, 2, 3, up to most of calculus 2, BC, it's really not that bad. If you can't get an A in it, it means you're not able to have a mindset of real success. Even if you're a little bit not math oriented, you should still be able to get an A in math and probably at least a 750 at least once on the SAT. And that's if you're not good at math. I promise if you think about it the right way, do what I ask you to do, it will work out. Here's the thing. If you do it correctly, this goes for all schoolwork, project, tests, whatever. If you are efficient, it doesn't actually take more time. When you're worse at a subject, it takes more time to do mediocre. That's a weird concept. You probably are a little confused as to what I'm talking about. Basically, what I'm saying is that you're unfocused. What feels like resistance, what feels like pain is just a primitive response. It's biological. You need to learn how to turn that anxiety, fear, and adrenaline into productive grades, games you play, a performance, a sport, whatever it might be, but you need to have control over that. To do that, we have to train our discipline like any other subject. We may not actually care about the math or whatever subject, but we need to trick ourselves or get good at tricking ourselves just for a little while that we do care about it. Speaking of, let's get to work. Here's how we're going to learn to do math. The way I'll teach it is called a case study method. What that means is we're going to look at a pretty complex problem, and by solving parts of it, we will learn the concepts along the way. And this introduces the second part of how we're going to be doing this, which is how you need to think about it and what a lot of my methodology, my process, the steps I'll take to solve problems and teach you them will be very conceptual. We call this the conceptual toolbox mindset. What that means is you want to think of math, school math up to Calc 2, Calc 3 as puzzle pieces in a puzzle. But if you understand really well how one of those concepts works, you'll actually be able to more or less figure the rest out on your own, or by only remembering about 80% of the actual information, but 100% of the logic, you can do it on the test. You don't have to always remember 100% of the formulas if you have a good idea of how numbers actually work. That's what the conceptual toolbox is really all about. Second, when test makers make a test, that's what they're doing. When test makers think of what's the point of this question, they really just think about what concept in this topic set am I pointing the student towards? What 2 or 3 concepts do they need to connect? Or which one of these concepts do they understand really well? And that's where the difficulty in the question is. Is it still the same concept, but now the way in which you understand it needs to be very in-depth, and that makes a problem tougher. That's how standardized math really works. They have to follow the same rules that you do. We can call this being goal-oriented. Again, if you just get good grades, A's in math, along the way, you might even have some time to learn something and enjoy it. Okay, enough talk. Let's start with a problem. Here's the problem. There's a number. You're given information about the number. What is the number? This is a type of problem that'll show up in a logic class, in a stats class, maybe in I'd say Algebra 2 class probably, maybe Algebra 1. Here are the properties of the number. It has exactly 3 unique divisors. It can be put into form a over b, where a and b are both integers. That's interesting. We'll come back to that. If we take the number to the 7th power, the resulting number is positive and odd. Okay? The number itself is less than 150, but greater than 100. Well, that narrows it down a lot. We've now narrowed it down from maybe an infinite number of options to a range of 50. I'm not going to say 50 numbers because I'm not sure if it's a fraction or something. We'll see what we get to. Where do we even start? First and foremost, let's remember that math questions have to be explained to us in English. If we're able to translate the English efficiently, let's say we know what to look for and immediately can know what concept box we're in, what sort of equation we're probably going to use, it makes the problem so much easier. And the issue a lot of kids have is they're unwilling to be wrong about that. It's okay if you're wrong about a concept, especially if it's really close to the one you're supposed to be using. It'll point you in the right direction. You need to just be active. What I mentioned earlier is it doesn't take more time to do math correctly, to do it well and efficiently. It takes more effort. You need to be a bit frantic sometimes. So when we look at the puzzle pieces with that little bit of intensity, we can just look at each line by itself. The last line, self-explanatory. And so we're going to look at one of the other pieces. Let's look at the third line. If we take a number to the 7th power, the resulting number is positive and odd. First, let's look for buzzwords. What we want to avoid doing is finding a buzzword and just inputting some random pattern. We need to finish saying the concept in our head. Here's an example. When I see this word in this context, 7th, in my head, I quickly think 7th power means take this number to the 7th power. Basically, take whatever it is and put a 7 on the exponent. Great. And that sounds more simple than the concept, and that's a good thing because your brain doesn't really think in exponents and derivatives, and these words are too foreign unless you are actively doing math 100% of the time, which most of you don't want to or aren't. So the point is we need to be comfortable finishing the thought in our head and not just figuring out how to use ChatGPT and put it into Delta Math. It's a very small adjustment, but there is resistance to it because it takes more mental effort. It takes you going from, I'm not making this up, this is psychology theory, from your right brain to your left brain, from thought to recall and back. We won't get too much into it right now. The point is there is biological research that shows that's how focus works, is if you finish this sort of thought in your head a little more completely, you will be more disciplined and have more accurate and efficient tests and math problems in front of you. If we follow the English, we get this equation then where x, a number, to the 7th power ends up being positive and odd. All right, those are the buzzwords. As simple as they seem, positive and odd mean certain things, and it helps us fit the puzzle pieces. These are the easy pieces, let's say. They're the edge pieces. What are those two concepts then? Positive means, quick side lesson number 1, positive just means this side of the real number line. And negative just means this far And on the other side of the number line, you can think of every single negative number as a negative in front of the positive version. If that doesn't make sense, essentially what it is any real number has a value away from 0. Negative just means it's the opposite of that. So when you do equations or expressions or any function, including exponents, anything you would do with a variable, you can just input a -1 times the number you have, basically saying negative you can always treat as -1 times the thing and then the function that you're doing to it anyways. If you ever have trouble with a tricky equation or trouble with negatives, write this step out with parentheses. All right, pause this and write something down. Just whatever you think makes sense, something in your own words. Even if you already knew everything I'm talking about, it's pretty fundamental right now. Still write it down in your own words and say it out loud. This is how we learn. I want you to get into that habit. Side lesson number 2. Most people know what odd means, but just to reiterate, if we were to split an even number, we would have 2 integer equal halves. If we split an odd number, we also get 2 integer halves and specifically 1 left over. So if we know the English of math a little bit and the logic, odd implies that this number is an integer. We didn't know that before, and this might be tricky to find during a problem, but don't ever assume a number is an integer. And we'll come back to what an integer means exactly. We'll go through the actual point of this lesson, which is a quick rundown of number theory. Back to the problem. What did we learn? It's between 100 and 150. The number itself is positive, which we already knew because it's between 100 and 150, and it's, quote, odd. What that means, it's probably an integer. Let's say we were taking a test and we weren't sure on that. We'll come back to if we can figure out other information to confirm that. But yes, odd in the language of math does mean it is an integer. I believe depending on the test and the way test makers usually use it, generally it implies positive as well. I don't know if negative numbers always count as odd. I legitimately think that's teacher by teacher. That's pretty good. We're narrowing this number down, especially if it's probably an integer. We do have some complicated English to work through on the first 2 lines of this puzzle. Let's look at it again. This second line about a over b is really interesting. The reason I included this is to illustrate that this statement, a number can be put into form a over b, a divided by b, where a and b are both integers, is actually the definition of what a rational number is. A rational number. In other words, a number that either ends or repeats. Think about it. That's really what a rational number is. Either the decimal ends or it starts repeating. We don't have to get into it now, but that actually does mean there is a fraction that represents that number. That's essentially what this line is the English of. I want everyone watching this to get used to that. That's a very common thing they'll do, is they'll say something that technically is actually just the definition of a concept, but because it's a real world example or a word problem, a lot of students aren't comfortable with that. Here's an example. This is literally just saying this is a rational number. We did kind of know that already from the fact that it's, quote, odd, which implies an integer, and an integer is automatically a rational number. Ooh, about that, side lesson number 3, we're going to do basic number theory explained in 60 seconds. Here we go. The set of natural numbers starts at 1 and goes by wholes, W-H-O-L-E, towards infinity. Basically, if a monkey started counting bananas, it would start with 1. A monkey probably doesn't understand the concept of 0, and then go 1, 2, 3, 4, 5. It wouldn't go 1, 1.5. It would be counting. Natural numbers are also known as counting numbers. The set of whole numbers is the exact same and just adds the number 0. Humans got involved. Integers include everything that the whole numbers include and the negative versions. So there's still no decimals in these. They're not fractions in the traditional sense. They are integers. Rational numbers are numbers that repeat or end. This list we've made so far Each line includes the one prior to it. We've already gone over the rational numbers. Write it out and really think about that. Repeat or end is the English in my head, but the A over B is the real definition. Finally, irrational numbers are numbers that do not repeat or end. Usually roots, pi, or e are the numbers you're going to interact with when talking about irrational numbers. Finally, imaginary numbers cannot be found on the real number line. That's the simple definition. Every other number, think about it, is somewhere on that solitary line. And the most common way you're going to interact with it, probably the only way with imaginary numbers, complex numbers, is going to be with I, the square root of -1. All right, back to the problem. Finally, we have the first line. Exactly 3 divisors. How can a number have exactly 3 divisors? This is a key point of my lessons. We have to think like scientists. Let's think of a number with lots of divisors. In between 100 and 150 even. 120. That doesn't quite work. Let's think of the divisors. You need to understand some words. If you don't know what that word means in a concept set, you're going to struggle with it. This is why math does require some repetition, but we don't have to spend too much time on it if we're thinking conceptually in the first place. The number 120, if we think about its factors, it starts at 120. They're paired off. 2, 60. We're already at 4. 3, 40. Way more than 3. Okay, that doesn't work. So we can't have a number that has too many divisors. We need 3 divisors, whatever that means. What about a number like 113? That's between 1 and 150? Well, 113 only has 2 divisors, 1 and 113. Hey, what does that mean? That means it's prime. Remember how I said a lot of word problems or quote unquote real world problems in school math will just say the definition of a concept and it's up to you to realize that's what they're saying. If you end up with a number that only has 2 divisors, if it says that in a problem, you want to connect that to the word prime. That's how we build this really good habit of connecting concepts to buzzwords. How does this help us solve our original problem, though? That's 2 divisors. So we need 3 divisors? If we think like scientists and combine the 2 numbers we just tested, we tested our hypothesis, we did some experiments, why don't we just try a random number? It feels like the divisors have to pair off. When would they not? Let's think. What about a number like 10? That's not between 100 and 150, but I want to just use another example or experiment. The 10 has 4 divisors, 1, 2, 5, and 10 itself. So do they always come in pairs? Could we hypothesize a number with exactly 3 divisors? Yes, the square of a prime number. If you didn't get there naturally, think about that list of 10. In the list of 10 numbers, 1, 2, 5, and 10, 2 and 5 are prime. So the only way we're going to be able to avoid having a pair of divisors together is if it is, and have exactly 3, sorry. If we're going to avoid having 4 divisors or 2 divisors, the only way we're going to have 3 exact divisors is if the number itself doesn't have another divisor except 1. Really sit and think about that, but it's the logic of it. We're essentially saying the thing we're looking for is the square of a prime number. You have to understand where the language leads. If you didn't know it, we still were able to get to that idea through some experimentation. Granted, I did make this problem, so I knew how to do it, but I think I would have been able to figure this out as a good scientist, as a good mathematician. I think you can too. At this point, really take your time, write this out if you need to, redo the problem. It's really not too bad once you think about all the pieces, but the real trouble and the real lesson is to think like that all the time. Let's get back to our original problem and just finish it out. We now know that the number is odd, which does imply it's an integer. It's between 100 and 150. It's rational and real on the real number line, which we already knew, but good to confirm. Positive, we already knew, but good to confirm. And it is the square of a prime number. If we take a look at the list of prime numbers, we'll quickly get too big for the square to be between 1 and 150. So we're not dealing with very many numbers. Let's see if we can narrow it down. The prime number list is 2, 3, 5, 7, 11, 13, and 17. The squares are 4, 9, 25, 49, 121, 169, boom, 121. This is the only number that fulfills all the requirements. We took a pretty complicated journey to this answer, and I don't want you to think that we have to do this every time with a math problem. This was a lesson. It was a case study. Even then, we didn't take longer than 10 minutes. If you take a long test and spend 10 minutes on the very last problem, that's fine too. And remember, this was a case study. I'll summarize all the concepts we learned today. That's what we really want to focus on. Building that toolbox for this set of concepts, which was a little bit of number theory and a little bit of positive, negative number line theory. We'll just classify this as number theory. And in terms of how you're going to use it, think of a few of those definitions we went over, such as prime numbers and what a rational number is, what an integer is, and the process of confirming our answer at the very end. We want to make sure that the English is right. Are we looking for the number itself or maybe the prime version? A lot of people might put 11, and at that point they would have done 99% of the problem and not just confirmed they were looking for 11 and not 121. If you're in a rush, you might forget the number has to be between 1 and 150 and you're looking for the square. I'm asking you right now for just 2 minutes, okay? Please, for the sake of your own ego and mine, write these concepts down and say them out loud. These are the things I'm about to follow up with that you will end up connecting and working through when you do standardized math. That's the purpose, remember, to get a good grade without silly shortcuts. These are the real shortcuts, the effective ones. I'm going to stop talking now and put up the concept toolbox just for a few seconds with some cool music, and it's on you to do the worksheet that's attached, watch this video again, and write it out in your own words. Till next time.